I think we can get started. Welcome, everyone. This is the Climate Resiliency Challenge, hosting a panel with one of our founding partners, Aon, on climate-related perils. If you're in the room, I'm assuming that you heard about this through one of our newsletters or through LinkedIn. So welcome. Thank you for your submission to the challenge within the next 2 weeks. I'll just plug here that our open submission ends on July 10th. So I hope you find some insights in this panel that help you update or make a submission. So I'm not gonna talk for long. I would like to introduce our guests from Aon. And today we're going to talk about climate-related perils. What are some of the current trends and laws that we're seeing? What are some opportunities in the solution space? And what are some things our panelists would like to tell you as people who are working in this area? So I'm going to introduce Megan, who will introduce her colleagues. Megan is one of our challenge mentors and managers. She's been on board for the past 2 months, helping us shape this challenge. She's also a doctor focused on climate risk. So we are very happy to have all of you here. So Megan, let's get started.
Yeah, thanks, Dennis, for the introduction, and thank you everyone for joining us today. Me, along with my colleague Liz Henderson, that's also in attendance here, have been really engaged with the IDEO team and Dennis and others from CSAA and our other partners in this challenge, because we feel very strongly that innovation is really the key way that we can solve some of these big problems. And so we're really excited to start seeing more submissions come through and more exciting new ideas that can help us in this space. But recognize that, in order to come up with some of these new great ideas, it's really helpful to have a strong foundation into what is the risk and how that could be changing into the future in cases where that might be more or less clear. And so today I'm joined by 4 of my colleagues from our reinsurance analytics team. We have a team that focuses heavily on understanding physical risk from key perils to help our clients to manage and mitigate this risk. Our clients in this particular part of Aon are typically insurance companies or reinsurance companies. And so trying to understand, what is the current risk and how do you manage through that? And so we've got a really strong model evaluation team that assesses the available tools to quantify risk across various perils globally. And we have experts in key perils across different regions. And so with me today, I have Katie Carter, who's the head of our model evaluation team for the Americas. I have Rachel Bonacorsi, who is our wildfire peril lead. I have Holly Wyden, who is our flood peril lead. And I have Laura Powers, who is our severe convective storm peril lead. So these are people that really understand the perils in great amounts of detail, in addition to how these perils can lead to loss essentially loss in community resiliency after major events. And then also understand sort of the state of play when it comes to available tools that are out there to better understand the risk and where are the gaps in our understanding and what we have available. So I will share my screen here. If I can figure out how to do, share screen, the giant green button at the bottom. And let me know if somebody can just give me a heads up when you can see my screen.
We're good.
Okay, perfect. Step 1 here. So here, my colleagues will be talking about insurance risk management challenges for climate-related perils, focusing on the key perils that are of interest to this particular challenge. So I did introduce all of these colleagues here, but a snapshot again of Laura, Rachel, Holly, and then I'll be muting myself for the next 30 minutes or so. But if there's any specific questions around climate change and the impacts on these different perils, then I'll plug in there at the end. So with that, I will hand it over to you, Laura.
Yeah, thanks so much, Megan. Thanks for the great introduction. So we can go ahead and start here with SCS. On the next slide, let's just start with some industry loss trends for severe convective storms. So one thing that we have seen over the past 30 years or so is that SCS loss really has become a larger contributor to the total insured loss. So here we're looking at total SCS loss by year, which is in the gray bars. The total from 1990 to 2009 is around 212 billion, while the total from 2010 to 2021 is 277 billion. So there's more loss in this most recent decade than there was in the two prior. In the first 2 decades, SCS represented about 33% of the total insured loss, while it is closer to about 50% in the more recent decade. And another thing that we see here is an increase in the contribution from the wildfire peril, which was 2% of the total in the first 2 decades and around 11% in the more recent. So Rachel will touch on that peril next. On the next slide, we are looking at how the number of significant SCS events has also increased over time. So green represents the losses in excess of $1 billion, and blue represents losses in excess of $2 billion. The event count by year is displayed in the bar chart, and we can see that really specifically since 2011, there's been a significant number of billion and multi-billion dollar events per year. All these losses have been trended to 2022 dollars, so that's kind of taken out of the picture. So we aren't just seeing the percent contribution from SCS becoming larger, but we're also seeing the magnitudes of the losses themselves also increasing. Now, there are many reasons that we could see this increase in SCS losses, and so we're going to discuss some of those reasons today. On the next slide, let's just start with the first obvious potential contributing factor, which is climate change. This is a really tricky one for SCS because the impacts of climate change on SCS activity are still uncertain. With some guidance released by the IPCC recently, it was noted that frequency or intensity may or may not be significantly impacted by climate change. There's just still a lot of ongoing research regarding this topic, and currently the confidence in the impact really is low. The issue is that there's kind of 2 ingredients that are conducive to severe thunderstorm formation, CAPE and wind shear, and they're both moving in different directions. So with increasing temperature, CAPE, which is a measure of energy in a storm, that will increase, but wind shear, which allows thunderstorms to kind of tilt and become severe, will decrease. So at this point, it's kind of a battle of which impact will ultimately prevail. Another thing that does make this topic tricky for SCS is the bias in the reporting and the localized fluctuation of significant weather. So if you go to the next slide, this shows this for each of the sub-perils. Could you advance one more so we can see? There we go. So we're looking at basically 2-decade views for each of the sub-perils here, and we're seeing how the frequency of the reports for each sub-peril changed between the 2 decades. With tornado, we do notice a slight eastward shift. This will ultimately increase losses because the population is higher in the southeast than it is in the central plains. For hail, we see a slight increase along the Rockies, which will impact the expanding cities in the Colorado area. And then for damaging wind, we see increasing reports of damaging wind across the central US and the eastern US. Another good example of these wind impacts are some of the derecho activity that we've seen over the past few years. So really, whether or not climate is impacting the sub-peril, there are changes that we see between these 2 decades. And then these changes have really gotten the insurance industry to start thinking about this peril a lot more. Next slide, please. Now, one thing that we do know for sure will increase the impact of SCS loss is an increase in population. So the map on this slide is showing population growth since 2000, and some of those larger growth states are highlighted in red. 2 states that we see highlighted in red here are Colorado and Texas, both of which have significant exposure to the SCS peril. This expanding bullseye theory, that's what they call it, that's what's demonstrated here. This just shows how a population increase can lead to an increase in both the frequency and severity of SCS losses. So when you think about it, if you have the footprint of a city expand outward, an event that used to be outside of the city is now impacting that city after the footprint expands. And so this actually increases the event frequency of that area. And then at the same time, when you have more people in that city, there's more homes, more businesses, more cars. And therefore, if a similar event hit the city as it did before kind of the growth in that area, you now just have more insured value to damage. And so the severity of the events increases. So with population expansion, you really have increased frequency and severity of SCS events, which ultimately leads to increased losses. And we definitely see this in both Texas and Colorado, and then there's other areas of the country impacted by this as well. So while the impact of climate change is more uncertain, this is definitely one area that we do have strong certainty about. Now, if you could go to the next slide, this is the last slide for SCS, and this just kind of lays out some challenges that we see with managing this severe convective storm peril in the insurance industry. The first is the expansive hazard domain. So SCS activity really happens all over the US, so claims are unavoidable. It's not like hurricane where you can avoid the coast, or earthquake, you can kind of avoid fault lines. You know, flood, you can only write certain elevations. Insurance companies just know that they're going to be exposed to this peril, and they just have to find a way to accurately manage and price it. This peril also has a significantly localized severity. You know, with something like tornado or large hail events, the damage is just at such a high resolution. So accumulation management is just critical to ensure the risks aren't too concentrated and could potentially all be wiped out with a single event. The last piece is really understanding the risks that are being insured, and this is a common theme across all perils. But understanding what risk characteristics really impact losses is just very important for insurance carriers. So with something like SCS, details like the roof age or the roof covering can have a significant impact on the claim, since most of the damage is done to the roof in the typical SCS event. You know, older roofs tend to be more easily damaged. Metal roofs just tend to be more impacted than asphalt shingle roofs. So it's ensuring that these data details are really captured and included in the underwriting process. That's just a very important piece of the puzzle. That's what I have for SCS, so I'll go ahead and turn it over to Rachel for wildfire.
Thanks, Laura. Just checking to make sure everyone can hear me. Okay, awesome. So yeah, I'm going to talk about wildfires. So if you want to just go to the next slide, Megan. I think that there really is agreement that wildfire risk has been increasing over the last couple of decades, but it's important to understand exactly what has been increasing and what has caused us to land in the position that we're in with the current risk landscape for wildfire. So if we were to look at the last 30 years of historical wild frequency, so the number of fires that have ignited on an annual basis, we don't necessarily see an upwards trend in fire frequency. So we're not seeing more fires fires today than we were seeing 30 years ago. But what we are seeing are larger fires. And that's what's being depicted on the graph here. In the gray bars, we're looking at the annual acres burned. And then the purple line represents that 10-year acres burn moving average. So if we're looking at the average acres burned from 1992 to 2001, we're looking at about 3.6 million acres burned on average for the United States. Compare that to the last 10 years or so. Now we're looking at close to 8 million acres burned on average. And that's about a 120% increase in the acres burned. So we're really seeing a clear trend that there are more large fires today than we've seen in the past. And if you go to the next slide, additionally, we are seeing more costly fires. So wildfires are becoming more destructive. And if we look at the graph on the left-hand side, here we're listing those US wildfire events that have exceeded $1 billion in insured loss. There's about 18 of them. Those events that are depicted in red represent the events that have occurred since 2015. And out of those 18 events, 14 of those have occurred in the last 8 years or so. So definitely more costly events in recent history. Similarly, if we're looking at the aggregate US wildfire losses on the right-hand side, if we look at the losses for 1950 through 2021, and that's a pretty big time period, 70% of those aggregate losses are being caused by events that have occurred just in the last 8 years. And so we're definitely seeing larger events, and we're seeing more costly events. And there are a few factors that are often attributed to larger events and more costly events. The first one is about a century's worth of very strict suppression policy by federal fuel management agencies. And so what we've been doing in the past is essentially putting out any fire that starts. And we know now that fire is a natural part of the ecosystem. It thins out fires. And when the conditions are right for not having a large wildfire, so low wind speeds, not super dry fuel, it thins out the forest and it actually prevents us from having some of these really out of control severe events. So that's one of the factors that we often attribute to it, some of this change in wildfire risk. Another factor is climate change. So now we have hotter and drier wildfire seasons. So is drying out that abundance of fuel that we have from those strict suppression policies more quickly than we've seen in recent years. And then the third factor is urban expansion. So we're seeing more people move into these areas that are at wildfire risk. So the combination of these things, we have more fuel that's drying out, that's leading to bigger fires, and then we're having more people being put in harm's way, that's leading to more destructive fires. So these are really kind of what is influencing this change in wildfire risk leading to where we're at today. The next few slides that I'll talk about are going to highlight some of those significant events that we've seen in recent history and talk about some of the lessons learned. We, as AON, had the opportunity, a few members of us at least, had the opportunity to go out to some of these different events and survey the damage following the events. And one of them was the Camp Fire. And what makes this event so significant is the fact that it was the most costly and deadly event in recent U.S. history. And so this event occurred in Paradise, California. It ignited on November 8th in 2018. It burned for just over 2 weeks. It destroyed 153,000 acres and destroyed 18,000 structures, causing about $11 billion in insured industry loss. And so what made this, this event so destructive was how quickly it moved through this town, this community of Paradise. So it ignited in the wildland area. And then because we had 50+ mile/hour winds, very quickly moved up this 800-foot canyon where the town of Paradise was sitting on the edge of, and then swiftly moved through that community that was very densely populated, and it was intermingling with the wildland vegetation. So trees were just throughout the community. So there was a lot of fuel right in that area next to the structures. Even though this was a very severe, costly, deadly event, we were still able to learn from it. And if you go to the next slide, we were able to learn from it by focusing on those few structures that actually did survive. So what we see here on the left-hand side is a map of all of the structures within the Camp Fire footprint as reported by CAL FIRE, their damage inspection report database. And so those points in teal, those represent the destroyed structures from this event. The points in purple reflect the structures that were surviving. And then there were a few structures that had some varying level of damage, but essentially the structure either destroyed or it survived. And what we saw from looking at this map is that homes that survived were often clustered together in groups, and they were often next to major roads. So one thing that this suggests is that fire suppression really came into play. And so because these surviving areas were often closer to roads, they had potentially more access to, or the fire suppression resources, the firefighters had more access to the communities to prevent the fire from spreading to them. Additionally, what this might suggest is the fact that because they are closer to roads, they might be in a more commercial environment that is going to have more non-combustible material. The buildings are going to be likely concrete building. You're going to have the concrete with the roadways. And so that could be acting as a fire break to prevent the fire from spreading to some of these areas. The other thing that we might be able to conclude from this is that community mitigation is coming into play. And we've learned that this is really critical in the survivability of areas when it comes to wildfire. And so what this kind of means is that just because one single home has done everything that they can to protect themselves from a fire reaching and igniting their home, if their neighbor is not providing or implementing the same level of wildfire mitigation in their fire, and that fire ignites their home, it's much more likely that that structure that has done everything right is going to ignite. So it's really, really important for these communities to take collective efforts to protect their properties, their homes, the surrounding area of that community. And we kind of see that come out to play when we see these clusterings of surviving risks in this event. So just because this was a very destructive event, we see some areas that we can learn from. Another area is the year built. So the CAL FIRE DINS data, the damage inspection data, also records the year built of each individual structure. And so we can look at different year built bands based on significant building codes. So we know there were some building codes changes in 1997. A really big one was in 2008 in California. And what this means is depending on when the structure was built, the structure would have been required to do certain wildfire mitigation efforts, like put a Class A fire rated roof on, maintain a certain level of defensible space. And we can see that these efforts play out based on the survivability of newer homes versus older homes. So post 2008, 65% of those homes survived relative to pre-1997, where only 31% of those homes survived. Another event that we were able to look at was the Marshall Fire event, and that's on the next slide. And the reason why this one is significant is because it occurred in Boulder, Colorado. And it was a very destructive event in an area that we maybe weren't expecting to see this level of loss. So this was a very quick event. It happened in 2021, right before New Year's Eve. It was only burning for a few days before it was contained. It was also a relatively small event. It only burned 6,000 acres, but it destroyed 1,000 structures and caused $2 billion in industry loss. And so this is significant because this was the most destructive or costly event in Colorado's history and the first event to surpass $1 billion. And so what made this fire so destructive was primarily the wind speed. So again, we're looking at wind speeds of 50 miles per hour, and that really drove the fire spread. It was a very fast moving fire and it made it difficult to control. And once we were seeing that fire breach the urban environment, it really destroyed a lot of structures. And so a few other things that we learned from surveying this event, on the next slide here, we'll outline those, is that there really still is differences in the type of fire. I don't know if it's just, there we go. And so this fire was predominantly a grassland fire, and a grassland fire is different than a fire that you would see burning through the forest land, the canopies in Northern California, for instance. The fire in a grassland fire is still going to be a fast moving event, but it is going to be less severe. You're not going to get the ember showers that you might get in a California or a forest-based fire. But if that fire breaches that urban environment and then you have structure to structure spread, it really becomes a different type of event. It is going to be much more intense, and now you're going to have those ember showers, and it's going to pose a much higher risk to the structures surrounding in those communities. So that is kind of what we learned from the spread of the fire. We also saw that building density played a really significant role in the survivability. Some of these structures were only 10 feet apart from one another. So once one structure went up, it was really easy for that other structure next to it to ignite and then continue to spread throughout the neighborhood. We learned that the firefighting resources were hugely important in this type of event, especially because it really all came down to whether or not a home was igniting to determine how that neighborhood survivability rate would become. So firefighting resources really played a big role in making this fire only a $2 billion event and not anything much more severe. And then wildfire mitigation also played a pretty significant role. Similar to what we looked at in the campfire, we're able to focus on some structures that actually survived. And we saw reasons why they survived. Some of them had multi-pane windows, some of them were further apart from their neighbor, more defensible space, and generally built with non-combustible materials. So we're able to identify some of those mitigation features that contributed to their survivability. And then lastly, kind of similar to what Laura talked about, there are some key challenges that insurance companies are facing with managing wildfire risk. The first one is really just the evolving hazard and how quickly wildfire risk is changing. And that goes back to that climate factor that I mentioned earlier. You know, with the hotter, drier seasons, that fuel is drying out. We're seeing much more intense conditions for wildfire seasons. Additionally, as I mentioned, was the urban sprawl. So more people are moving into this environment. That changes the risk, and that's constantly changing over time with urban expansion. Then we have the exposure growth kind of playing into it in terms of accumulation. So the insurance companies have to understand their concentration risk and how that relates to that evolving hazard, which is really challenging. It is kind of like a moving target. So they have to understand how much exposure they have in certain areas and what the risk is to that area and what that might look like relative to the industry. So if an event were to impact that concentration, can that result in an outsized loss relative to the industry? And then lastly is that understanding the risk. So we really didn't put a lot of importance on risk characteristics until recent years, when we had all of this activity and people were paying more attention to wildfire, and we started to understand the importance of some of these mitigation features. And so that's still something that we're trying to understand is we know that they're important, but how do we quantify the importance of the roof type, of the defensible space, of wildfire protected vents. And so as an industry, we're continuing to collect this data. We're continuing to try and educate homeowners to mitigate their homes as well. And then property management and community resilience kind of go hand in hand. We have to protect our neighbors. We have to make sure that the community is taking steps to protect itself, to make sure that every individual property within that community is going to be protected if a wildfire event were to impact that area. So just kind of last statement here, you know, wildfire has its challenges for the insurance industry, but it also has challenges for homeowners, businesses, state legislators, and it's really kind of an unique peril where we all have to work together to make sure we're educated and mitigating our properties and understanding the risks so we can make sure that we can prevent some of these really severe events that we've seen in the last few years. And with that, I will pass it to Holly.
Thanks, Rachel. Hopefully everybody can hear me as well. Awesome. All right. Yeah, thanks, Megan, for the, the thumbs up. All right, so we'll get to the next slide here before I make the big statement. Flood is the most frequent peril in the US, and the risk is increasing, right? So since the year 2000, flooding has actually caused over $850 billion in damages, which has accounted for roughly 2/3 of the cost of all natural disasters in the US. Now, this might seem a bit high to some of you, but you have to keep in mind that the majority of natural disasters in our country actually involve flooding. So, you know, keeping in mind that storm surge, right? Even though it's associated with hurricanes, it's still a part of flood. Also, tropical induced precipitation that can cause flood. Severe convective storms can cause flood, things like that. But one important thing to note for the insurance industry is that there's a significant insurance coverage gap that leaves much of these losses uninsured. So for example, roughly, I think it was almost like 80% of homeowners that were impacted by Hurricane Harvey, is a very significant amount, actually didn't have insurance. I know it was very, widely broadcasted in articles too, of like how many were outside of designated hazard zones. It was like over 70% or something like that. And this comes down to the lack of understanding of the risk. So as many of you may have heard, flood insurance is only, or may know, flood insurance is only mandatory for certain flood zones deemed hazardous or more hazardous by FEMA and the NFIP, which is the National Flood Insurance Program. But just because you're outside of these higher risk zones doesn't mean that your property can't get flooded. So, you have an event like Harvey, which had unprecedented rainfall. Unfortunately, that event ultimately proved this point. So again, we have to rethink about how we educate on flood risk, even just the current risk, let alone the future. Now, as our country's population continues to grow, so does our urban landscape. So we have more fields and forests getting paved over and turning into impervious surfaces, which increases the runoff of rainfall versus it being absorbed into the land. And this leads to more flooding. And on top of this, we have high confidence that climate change is increasing the frequency and intensity of rainfall and generating sea level rise that will exacerbate our flood events. And not only in the US, but also in other places around the world. And we've seen this in Pakistan, we've seen it in multiple areas of Europe, like Germany, for example. Next slide, please. Thanks. So diving a bit further into the impacts of climate change, the rising temperatures in the atmosphere and warming sea surfaces are influencing the precipitation patterns that impact us. So since warmer air can absorb more moisture, the potential for heavy rainfall increases. And, we talked about the IPCC reports. Numerous scientific studies that were analyzed by the Intergovernmental Panel of Climate Change indicate that these conditions will likely rise or lead to a rise in flash floods and river floods in many regions of the world. So this figure on the slide here shows the increases in intensity and frequency of extreme rainfall in the US only under different climate change scenarios. So we've got low, medium, and high basically scenarios of emissions, right? Or that are determined by, the different levels of greenhouse gases, as well as the societal or social economic factors that may impact how we, meet reductions in emissions over time. And as you can see from the top row of these maps, even in the low emission scenario, the increase in extreme rainfall is significant particularly across the Southeast US, as well as the coast of California, which gets impacted by atmospheric rivers, which have been in the news quite a bit this past year, and have a high population, as well as pockets in the Midwest and the Northeast that also have high population. Next slide. You know, and then there's the coastal side, the coastal flooding. That is going to continue to increase as well due to the combined impacts of sea level rise and storm surge. So this figure here highlights coastal regions susceptible to sea level rise due to climate change, where the Southeast and the Gulf Coast are also regions of significant population and economic growth. And this, you know, the coastal region, particularly across most of the eastern seaboard, actually has, you know, supports a lot of significant industrial infrastructure. So there's major, you know, multiple major seaports, many of the nation's largest petroleum refineries, there's chemical and energy corporations, aerospace and defense industries, all located kind of near or close to the coast, and all of which are very vulnerable to these, or particularly vulnerable to these climate change impacts. Now, construction brought on by, you know, urbanization in these areas is going to be impacted by the increase of the groundwater table as well. And this, it basically exposes foundation systems to saltwater intrusion, and saltwater causes corrosion, right, which is an additional kind of impact and a loss driver. So having that increased saltwater water intrusion can lead to some unexpected expenses for building owners. And in addition, high water levels that are, you know, increasing, so higher water levels, are going to elevate the risk of storm surge inundation and sunny day nuisance flooding. You know, so again, thinking about that increase of the extent, you know, that was talked about by my colleagues as well with severe convective storm and wildfire, right, impacting additional exposures or impacting additional buildings than it used to. And we've heard a lot about this with Miami, right, this kind of nuisance flooding where even a casual, you know, thunderstorm in the afternoon can actually generate some flooding in the streets of Miami. Next slide. Now, thinking about recent events and some of the things we've learned, like Rachel talked about as well, one of the things that stuck out to us while we were conducting some reconnaissance after Hurricane Ian last year was that flood mitigation efforts make a difference. Many of you may recall that Ian made landfall in southwestern Florida as a Category 4 hurricane on September 28th and produced catastrophic storm surge in Lee County and western Collier counties, particularly impacting the Fort Myers area and Naples. And then they also, the Hurricane Ian also impacted other parts of Florida by causing freshwater flooding across much of the central part of the state, as well as the northeastern part of the state. Now, we've estimated Ian to be responsible for roughly $95 billion in damage, making it the most costly hurricane in Florida's history and the third costliest in US history. So this puts Ian just behind Hurricane Katrina and Hurricane Harvey. It's very, very significant. And we've also estimated over 40% of those losses to be uninsured. So again, thinking about that protection gap with respect to flood. Now, Hurricane Ian had, you know, just some kind of other stats here. It had 155 miles per hour sustained wind speeds, which generated, you know, roughly 10 to 15 foot storm surges in Lee County. And this damaged over 52,000 structures in that county alone. And although many of us think about how powerful hurricane winds are, water can also be incredibly powerful, especially when it's driven by those intense winds. So there's upward forces, you know, of buoyancy, there's lateral forces that are exerted on the sides of the building, inside and outside the structures. There's impact forces and scouring that can occur with wave action. And often with storm surge and high velocity floods, debris is carried with the water and can cause further damage as it moves across land and impacts structure. Next slide. So as I briefly mentioned, you know, we noted quite a few different examples of flood mitigation while we were out in Southwest Florida and noticed some positive outcomes after the hurricane. And one of the main and probably most common mitigation efforts is to elevate buildings, or at least the first occupied floor. And seeing this along the coast these days is actually quite common because newer constructions have to adhere to stricter building codes and flood prone areas than, back in the, 70s and even 60s. But in addition to building elevation, we also saw instances of elevated service equipment. So thinking about even elevated heating and cooling units of a residential building. We also noticed instances of dry and wet floodproofing, which either keep the water out or let it pass through to alleviate pressure on the surface. So you can see a great example of wet floodproofing in the form of flood vents in that picture of the residential building on the bottom right. You can see the vents there along the bottom of the structure, then allowing that water to pass through and alleviating that pressure and making sure that they're mitigating against flood damage. And then one of the last things to note here, we saw some evidence of flood barriers that were deployed before the storm to protect businesses in downtown Naples. So you can see this example in the bottom left, where you have these little, areas where you could see the flood barriers being, secured into the buildings. And after examining some of the high water marks in this area when we were walking around, we could see how the protected businesses were able to quickly open back up. And while others, even just across the street that were not protected by these types of mitigation efforts or barriers, were still closed weeks after the event. All right, last slide here. Now, so as the others did here, I'll sum things up by hitting on some of the challenges that our clients and their insurance companies face when managing flood risk. So first off, as others, my other colleagues have mentioned, it's challenging to understand and estimate how the risk to flood may evolve over time, for their books of business or what they're on the hook for, so to speak. So for example, the current exposures in their portfolios could actually become risky with increased sea level rise and increased precipitation from climate change impacts, where maybe they weren't risky before. Also, increased urban development can alter what that risk landscape looks like by creating that additional runoff that can lead to larger flood extents and impact exposures that weren't previously at risk. And last but not least, we know that we're going to see events in the future that we haven't seen before, and that's hard to anticipate and prepare for. And why the insurance industry leverages probabilistic catastrophe models, which encompass thousands of simulated plausible events that can be used to assess potential risk that goes beyond our limited historical record. However, one thing to note here is that the flood catastrophe models are still relatively new. They require a ton of high resolution data, as well as advancements in technology and computing power. And in the past, these weren't quite up to the task of appropriately modeling such a high gradient peril like flood, right? That's also influenced by antecedent conditions, where the timing of an event and the succession of events is an extremely important factor and can exacerbate flood. So that said, there can also be significant differences among the model results, particularly at the location level. And this is partly due to the varying approaches that developers can take when they're trying to model flood. So you can model it in multiple ways, but also due to the lack of available claims data to validate the models, right? To validate and calibrate them and make sure that they're producing, more accurate results, which is a result of that insurance protection gap that I have previously mentioned. So many of our clients actually face the challenge of getting potential false precision of, with that modeled output, particularly when they're not as confident in the quality of their data, which is my last point here. And data quality and completeness may be one of the most important aspects of flood risk modeling and assessment. Like severe convective storm and like wildfire modeling, location is so important. We can't stress enough how critical it is to have accurate location information for flood in particular too. For perils like wind, you can kind of get away with street level or maybe even postcode level geocoded data, but not flood, right? The risk can vary greatly, within, if you put a location or a building in the street, that would flood more often than it being, on the, in the actual plot or parcel where you likely have an elevated ground underneath you. In addition, the risk can even vary across large buildings that have different points of elevation along its perimeter. So we've seen that with, larger commercial buildings or industrial facilities, for example, and that's another, challenge to tackle. And then last year, I'll just make a point that there's also unique exposure attributes that are really critical to flood that aren't typically captured in our industry. So things like first floor height and basement presence, these can have a huge impact when estimating the risk and potential losses from flood in models and other solutions. So by kind of bringing us back on a positive note here, I would also be remiss if I didn't mention that there have been a lot of advancements. There's been a lot of insurer tech companies and data companies that have really worked to tackle the issue of data quality and completeness, as well as new AI and machine learning techniques to better leverage the data that we do have so we can make smart assumptions from it when that information is unknown. So with that, I will pass it back to Megan, but we can also open it up for questions.
Thanks, Holly. And I just want to say thank you to all my colleagues for joining us today. I think what's also interesting from my perspective is not only noting the increases in losses and in some cases where it's more clear the actual risk of the hazard, but we're also seeing more compound events as well across these different perils that I think is really important to recognize. So if we think about, Holly's talking about more precipitation, so we have more vegetation, and then you hit the dry season in California, and now you have more fuel for wildfire. Or if you have a wildfire, and then suddenly you have an extreme precipitation event, now you have the opportunity for landslides. And so you really can't think about each of these perils in isolation, and really just 1 + 1 doesn't equal 2 here. So thank you again to my colleagues, and maybe I'll pass it over to you, Dennis.
All right, thank you, everybody. That was very informative and a lot to think about for where opportunities are to contribute to solution space. I want to first encourage everyone in the chat and in the Zoom call to type your questions in the Q&A section of the Zoom call so that we can take them and respond. And while you're thinking about your questions, or if you're curious about anything, I'll ask the first question to our panelists, and that is, given the sort of risks and current needs that you overviewed for each of the perils, what are some opportunity spaces for prevention, preparedness, or recovery? What are some sort of solution space ideas that you would suggest our participants look into, if that makes sense? Or I can ask it this way.
No.
Okay.
I will hit on I saw somebody mention in the chat about a solution involving promoting and making it easier for homeowners to employ preventative landscaping. So I think one of the big issues with wildfire that a lot of organizations are taking it upon themselves to work towards is homeowner and community education. And so helping the homeowners, policyholders, business owners, anybody that might be exposed to this risk, what their level of risk is and what are those steps that they can take to mitigate their home. I think it's interesting, going back to that Marshall Fire event, when I was out there and kind of looking at that landscape, you don't necessarily immediately think I am at risk to wildfire. And so helping some of those people understand you are at risk and what that risk level is, or what's the probability that that type of event might occur, is only going to help motivate them to take those mitigation actions to their home. And the landscaping issue is actually a really kind of unique one, because the mitigation actions to take there really aren't that aesthetically pleasing. And so a lot of homeowners find it challenging to, cut back all their trees and their brush, replace their bark mulch with rock and get rid of some of the really beautiful plants. And so maybe a solution there is trying to help them understand there's still really aesthetically pleasing solutions that are going to be wildfire resistant. And it doesn't necessarily have to be at a high cost. And so really it just goes back to the education. What are some of the steps that they can take to protect their home? What are the effort and the costs associated with that? And how will that improve their risk to that individual peril, wildfire specifically?
Yeah, I can build off of that as well. You know, I think the education piece can really, you know, be important for all of the different perils. I mean, I think at least the ones that we've talked about too, right? Where, you know, you might think, oh, like it's very unlikely that I'll get, you know, my house in particular get hit by a tornado, or that I'd be impacted by flood. I'm not even along the coast. I'm not even next to a river. You know, I'm not. And this, we haven't seen one before, right? Those are common responses that, you know, you get when you talk to people about risk of these natural disasters. And so education is a very, very important tool. And I think with flood in particular, as I mentioned about the mandatory flood insurance, right? It's super, super limited to these areas, again, near the coast or along rivers. It's not accounting for, you know, areas of urban risk. So that is something that's, you know, that's missing. And so when, you know, you're going to buy your home and you're looking at these outdated kind of products that, you know, NFIP and FEMA have, and that tell you, oh, you'd have to have flood insurance, right? It should be more of a conversation about like, well, you may not be in these particular areas that are mandating it, but you are still at risk, right? And how we get that data and that information to the homeowner, right? And be a part of that conversation, maybe offer flood insurance in a package and say you actually have to decline it versus, oh, would you like this? Like it's a choice for you, right? And as an additional cost, and we have to think about it differently. And I just wanted to make a quick comment. I really like what Megan said. I think a space, you know, in the industry kind of as we think about opportunities to collaborate across disciplines and across industries is really on this compounding, you know, catastrophe idea, and, you know, thinking about ways to improve mitigation and not get surprised that, you know, we can have a catastrophe and then another one, or that they, you know, they influence each other and have these significant impacts. Also, you know, with the different, you know, insurtech companies that I talked about, we have climate change models, we have catastrophe models, we have data companies. Like, let's all figure out a way to connect these tools, right, and provide what we need to, you know, provide what we need to make our place more resilient, our world more resilient. So I'll stop there. I feel like I'm rambling.
That was great. Thank you. Does
Sorry.
anybody in the, oh, I was about to say, does anybody have a question? So go for it.
Hi, I'm Dragoș. I'm from Romania. I would like to ask a question to Rachel. Who do you think should be responsible for educating about wildfires in particular? Because I'm preparing a solution on wildfires. So I studied quite a lot. I read some strategies and I found a gap, you know, like actually an issue with communicating the risk to, like, you know, the population. So I was wondering, who do you think it's responsible for educating on this? Because you have, you know, Smokey Bear in the US. So this is the question, Haley.
That's a good question. You know, Smokey Bear is an educator in terms of not starting the fire, but I don't necessarily hear him talk about replacing your roof. So traditionally, when it comes to the party that is responsible for providing homeowners with that knowledge, it's kind of always been the insurance industry, right? The insurance industry dictates that risk based on the price. of their insurance. And the insurance industry can inform the homeowner of what things they could do to their home to lower that price. And so with wildfire, it's kind of tricky because especially in California, we have legislation and regulators coming into play that are controlling that price to a they're very strictly controlling that price without getting too much into the weeds on this. So it makes it hard for that price to truly reflect the level of risk. And so it does leave a gap in the education. And I think that now, because everybody's trying to understand this risk and it's so rapidly evolving, everybody is responsible, right? You know, the homeowners have to kind of take it upon themselves to do their due diligence and do some research to protect their home, because ultimately, if they are at risk and a wildfire happens, they are really the ones that are at loss. And so the homeowners have to be responsible to understand that they are at risk. I think that the insurance companies have to be responsible to communicate back to the homeowner what they view their risk is. So we're transferring some of that knowledge there. State legislators have to be responsible to making sure they're stepping in the right place and not causing more problems with that knowledge transfer based on how like the pricing works. You have other organizations that are mandating building codes too, right? So that's another area that is going to influence the risk and be an opportunity for people to understand the risk, because they're building a house now, you know, they have to implement certain features to align with building codes. Hopefully they're asking them questions and they're understanding why they have to do that. So, I mean, honestly, it's everybody. Everybody has to play a role for us to kind of move forward and get out of the situation that we're in. So I know that's not a direct answer, but it's kind of tricky.
But do you consider the root cause? Because 9 out of 10 wildfires are ignited by people, right? So this is the statistic I've been reading. So I think a good focus should be on educating for, you know, not starting a fire in the first place, right? Because, for example, a community might be affected by a wildfire that started 20 miles away from the community by someone who went like camping and they forgot to put out a campfire, right? So this could happen.
Yeah,
so
absolutely.
I'm wondering if you have like some statistics on ignitions, like the causes. Is there such data available?
Yep. So the U.S. Forest Service does a really good job in collecting ignition data, and for each ignition, they do have a ignition source, and so we can tell. I'm gonna throw a number out there, and Katie Carter, you might be able to correct me, but I think it's something like 90% of all ignitions are human caused. And so, yeah, I mean, that's a really good point. Everything that I was talking about is really mitigating the home and preventing destruction and lowering that like the insured cost. But what you're kind of referring to is actually the frequency component. And, you know, home actually like educating the population, educating the community to not start fires, like that is huge. But another big contributor to wildfire loss are the utility companies. And so the utility companies are actually also making a lot of steps towards reducing their liability towards utility caused ignition. So they are burying power lines, they're doing mandatory shutoffs and high wind events. So again, it's the community understanding how they are igniting fires and starting these, going back to like the gender reveal parties and like the fireworks that'll start ignition from that. There's so many different ways that these fires can ignite, and just making sure that people are aware of what those severe fire weather conditions are like, making sure they're extra careful during those periods of time so that they aren't starting some of those ignitions. Again, the utility companies can't really prevent the lightning fire, ignited fires, but again, those actually are a relatively small portion of the total frequency of the fires igniting.
I think that I'll just add, we're dealing with human beings here, and just by nature, humans have short memories and maybe limited memories in terms of what they want to remember. And so there's a couple different pieces of that. One is if an event hasn't occurred recently, it's not top of mind. And number two, the need to really continually educate on some of these risks versus like hitting a community once every 10 years. Because they'll think about it for the next 30 days, but that's not sufficient. So I think there's like a psychological aspect to this too.
Absolutely.
May I ask another question?
We are at time, so if our speakers have like 5 more minutes, we can stay
Okay.
a little bit longer. And also, if there's any other questions, you're welcome to write them in the chat and we can address them afterwards as well. Okay, let's do one more question.
Okay, should I ask the question or is someone else? Okay,
Uh,
I was wondering if there are any public broadcasts, for example, in California, right? When it's the fire season, do you have these broadcasts on television, for example, saying, hey, don't start a fire today, or something that warns on, wildfire? For example, we have these public information campaigns on television here in Romania regarding like sugar consumption or alcohol. So I was wondering if you have something similar in your country.
Yeah, we do have, maybe somebody can correct me here. It might be NOAA that produces those, but it's severe fire days, and they do that across the country. I feel like I think I've even got like a push notification to my iPhone in the past telling me that it's a severe fire day, and I'm in the middle of the country. It might not be as widely communicated as to what that actually means. And so maybe the organization that actually does that could do a better job in helping people understand, like, this is what this actually means. If you were to ignite, if you were to, light a match, you could result in a pretty significant event. So I think there probably could be more education around that notification system.
Okay, thank you very much.
All right, thank you everyone for coming. Really appreciate your time and your insights. If any of the participants have questions about the challenge or you're preparing for submissions, please email us at climateresiliency@ido.com. If you have any thoughts or if you would like some one-on-one mentorship. So I will put that in the chat, but we will wrap here for the day. Thank you everybody for coming.
Thanks so much. Everybody take care. Have a good weekend.
Thank you for having us.
Thanks for having us.
Ciao. This weekend. Bye.